Hey, my math 30s. The next lesson that we're going to do is permutations with identical objects. So our last lesson was distinguishable or distinct objects where you could tell the difference between them. In this one, we're actually going to have some things that we can't tell the difference between, so identical objects. So at the top of your notes package there for this lesson, it says investigation. It says using colored pieces of paper, select two of one color and one of another color. So you can do this with anything. If you have two decks of cards, you could pick two four of hearts and an eight of spades or something like that. Just anything where you have two of one color and one of another color. So when I did it, let me grab a pen. So when I did it, I had two purple papers and a red paper. So these two purple papers are identical pieces of paper. You can't tell the difference between them. There's no marking on them. So just thinking about the ways that it says using the sheets of paper to fill in the chart below, record the number of different ways that they can be arranged. You may or may not need to use all of the rows given. So again, we have arrangement. So since it's saying something like that, we know that order matters. So I could have a purple sheet first and a purple sheet second and a purple sheet third, or a red sheet third, sorry. I could have a purple sheet first, a red sheet second, and a purple sheet third. I could also have the red sheet at the beginning and a purple sheet and a purple sheet. So in this case, we actually only have three possible arrangements because if I did a different purple sheet first and a different purple sheet second, that's not different than our first arrangement, arrangement one here. So purple, purple, red is the same as purple, purple, red. So we actually can't do that. So in this case, there are only three possible arrangements because again, the problem is we have those non-distinct objects. If you found more than three, you obviously, or you potentially were not thinking about how we've talked that they are identical objects. We can't tell the difference between purple, purple, red and purple, purple, red. Which were each of your sheets or whatever they are, objects distinct or non-distinct? They were non-distinct. So we only had two colors for three sheets of paper. Do you think it would make a difference if some of the sheets were different? I guess that should probably say all of the sheets. All of the sheets were different. Yes, it would make a difference. We would have more arrangements, more possible arrangements. And so again, from the last couple lessons, we would have 6 possible arrangements in that case. And so this situation is different than the last couple days because again, some of the objects were identical or non-distinct or non-distinguishable. Lots of different ways that you can kind of write that. So on page 8 or on a recent page, we looked at different ways to arrange the letters of the name Jim. So we could say JIM or JMI or MIJ or MJI or IJM or IMJ. We looked at that and we found the 6 possible arrangements. But it says, new question, it says how many ways can the letters of the name Bob be arranged? And again, we can't tell the difference between these two B's. They are the same. So we could have Bob as it is. We could have BBO, or we could have OBB. So there are three possible arrangements. With, again, those B's being identical. I know when I'm drawing them, they don't look identical, but if you look here, they look like the same B. So that's what we're talking about with these questions. What if we had the name Bill? I'm not gonna, don't worry about this calculation part yet, unless you've figured it out, but probably not yet. So Bill. So try doing Bill if you can. So I have to look at my sheet because I know I'll miss one. So Bill, or you can pause this and try it yourself. Oops. So in total there, hopefully I got them all down, there are 12 possible ways for the letters B-I-L-L to be arranged because again, two of the L's are the same. So hopefully you didn't find something that's not up there. I might have written stuff wrong. Yeah, I can already see that I wrote stuff wrong because this should be L-I to make it different than the one above it. Hopefully I got the rest okay there, or hopefully you didn't find something I didn't write, but there should be 12 for that one. So now don't worry about all this silly stuff in this. Don't have time for this right now. So now we have Lil. So Lil, if we wanted to organize them, so it's not Lily, it's Lil. So, oh geez, what have I done? So we could have L-I-L-L, L-L-I-L, L-L-L-I, or I-L-L-L. So I get 4. So now in this case, we have 3 things that are non-distinct. So we have 3 L's. And then the last one, pretty tough to do. So it's Lily, but spelled L-I-L-L-I. So we have 3 L's, 2 I's. So trying to do this is actually super irritating. It's not that many, but just trying to keep it all straight. Since I's kind of look like L's. Oh, I've totally lost my spot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hopefully you only found 10 as well. So again, arranging, none of those look the same. So we have 3 L's at the beginning here. You see we don't have that another time because you can't distinguish between any of those 3 L's. So the next part, it says explore when arranging objects that are identical or non-distinct. We have fewer possible arrangements compared to when all the objects are distinct. So again, when we had the letters J, I, M, we were able to find 6 ways to arrange it. And so again, that was 3 factorial equals 6. But when we had Bob, we only had 3 possible ways to arrange. So we have the same number of letters, 3 letters, 3 letters, but these are all distinct. This one has a repeat. So we have fewer arrangements compared to when all objects are distinct. This is because some of the arrangements are repeated. So we could find 6 ways to arrange BOB, but we wouldn't be able to tell the difference between BOB and BOB. So again, with those those identical objects, we can't tell the difference between a particular arrangement. So it says that is when a list of all the arrangements is made, some are exactly the same. This is a bit like the intersection of Venn diagrams when some arrangements are counted more than once. So it says, therefore, we need some way to remove these repeating groups. So in the L-I-L-L example, so that's that LIL example, we had 1, 2, 3 L's. The L's can be arranged 3 factorial ways. So that's in total, so 3 factorial is equal to 6 because 3 factorial is 3 times 2 times 1. So 3 factorial is 6 for every grouping. Since only one of these is distinct, we only want to count them once. Therefore, we need to divide any calculation by 3 factorial so that we do not count the same arrangements multiple times. So our general formula for this one, so it says in general, to determine the number of permutations with repetitions. So let's put a big underline underneath this. So we only need to use if there are some repetitions. Some repeats. So if it's a letters thing, if it has repeated letters, if it's a pathways question, if you're repeating the direction that you travel, if there's cars that are identical or something like that, we have repeats. So what this represents, so this is our formula for this. So for our number of different arrangements. So to determine the number of permutations with repetitions, so permutations is equal to n factorial. So n is representing, oh, it's right here, n is representing the total number of objects where A are identical, B are identical, and so on. So it's n factorial divided by A factorial, B factorial, C factorial, and so on. So for the example of L-I-L-L-I, so we had 5 things that needed to be arranged, 5 letters, 1, 2, 3, 4, 5. But we had some repeats. So we had a repeated letter of L, and we had it repeated 3 times, 3 factorial. We also had a repeated I, so that's 2 factorial. So 5 factorial, let's see if I can get a calculator, or 5 times 4 is 20, times 3 is 60, so that's 120 on top. 3 factorial times 2 factorial, 3 factorial is 6, 2 factorial is 2, so that's 120 divided by 12 equals 10. So if you look back at our Lily arrangements, there were 10 possible arrangements for that. If we do some of the other ones, so Bill, so again, Bill, there were 4 letters. We only had one thing that was being repeated, and that was the L's, so there were 2 L's. So that's 4 factorial divided by 2 factorial. 4 factorial is 4 times 3 times 2 times 1, which is 24. 2 factorial is 2 times 1, which is 2. So 24 divided by 2 is equal to 12. So if you have repeats, again, you take your total number divided by whatever is repeated on the bottom. So factorial of whatever is repeated on the bottom. So sometimes you might have more than one number. So in kind of our general form, that's why it has A factorial, B factorial, C factorial, dot, dot, dot. But sometimes you'll only have one number on the bottom if there's only one thing that is actually repeating. So that is it for this lesson. do some practice. Look over my key for the 6 questions because the last one's a pathways question, which you would have done a little bit of in 20-2, but in this one we're thinking about it in a little bit of a different way. So peek at that and check over my key. You're going to move on to combinations next, so you really need to be able to understand permutations in order to um, make sure that we keep it separate when we get to combinations. So thanks, guys.